Welcome back to part 2 of the lesson on exponential functions. We're studying functions in the form f of x equals a times b raised to the power of x, which are called exponential functions, where the value of a is the initial amount or starting amount, the base b is equal to 1 plus r, where r equals the growth rate per unit of time. So if the base b is greater than 1, then r is greater than 0 or positive, and therefore we have exponential growth. If the base b is between 0 and 1, then the growth rate r is less than 0 or negative, and therefore we have exponential decay. Let's go and take a look at our second example. You purchase a new car for $24,000. The car will depreciate at 12% per year. Again, we're asked about an exponential function to model the value of the car v of t after t years, then predict how much a car will be worth in 3 years, and then part C, when will the car be worth half of the new purchase price. Okay, so our function v of t is going to be in the form of a times b raised to the power of t. Remember from before, a is equal to the initial amount, and here we're just told that v of t is equal to the value of the car. So the starting value of the car is $24,000, so a equals 24,000. Now the car is depreciating or losing 12% of its value each year, so r is actually going to be negative 12%, which equals negative 0.12, and therefore the base b, which is equal to 1 plus r, is going to be 1 plus negative 0.12, which is equal to 0.88, which means our function for the value of the car, v of t, is going to be equal to 24,000 times 0.88 raised to the power of t. So notice here the base is 0.88, which means we have exponential decay, but because the base is 0.88, if the car loses 12% of its value each year, that means it retains 88% of its value, and that's why the base is 0.88. Now for part B, we're asked to determine the value of the car in 3 years. So using the function that we just found, we want to determine the function value v of 3, which is 24,000 times raised to the power of 3. Now it doesn't tell us where to round, but we'll go ahead and round to the nearest dollar. So back to the calculator, we have 24,000 times 0.88 raised to the power of 3, enter. So to the nearest dollar, we would say approximately $16,355. So as a sentence, after 3 years, the car is worth approximately $16,355. Now the question may say round to the nearest cent. In this case we weren't told, so I'm rounding to the nearest dollar. And finally, for our last question, we're asked to determine when the car will be worth half of the new purchase price. Well, if the purchase price was $24,000, we would determine the value of t when v of t would be equal to half of 24,000, or 12,000. So we want to solve the equation 12,000 equals 24,000 times 0.88 raised to the power of t. And again, we'll solve this 2 ways. We'll first solve it graphically. So we'll enter the right side in y1 and the left side in y2 and determine the point of intersection. And of course, we'll have to adjust the window as well. So y equals, clear out the old functions, enter the new function, so 24,000 times 0.88 raised to the power of x in y1, enter, and y2 will be 12,000, enter, and now we'll adjust the window. Let's change the x-axis from -5 to, let's say, 30, enter, and let's change the y-axis. We know we have to go up to at least 24,000. Let's enter a y max of 30,000, and we'll enter a y minimum of, let's say, -3,000. this doesn't work, we can always come back and change it. Let's go ahead and change the y scale to 1000 and graph. There's the exponential decay function. And here's the constant function y equals 12,000. We want to determine the x-coordinate of this point of intersection, so we press second trace for the calculation menu, option 5 for intersection, and enter 3 times. So we have x is approximately 5.42, or in our case it would be t. So graphically, we have t is approximately 5.42 years. Now let's also solve this using logarithms. So we isolate the exponential part of the equation first by dividing both sides by 24,000. Simplifying, notice how the left side is going to be 1/2 or 0.5 equals, on the right side we have 0.88 raised to the power of t. Again, we'll take the common log of both sides of the equation. And now on the right side we apply the power property of logarithms, so we take the exponent of t and write this as a product. So now we have the common log of 0.5 equals t times the common log of 0.88. And we'll isolate t by dividing both sides by common log 0.88. Simplifying, we have t is going to be approximately equal to this quotient here, which again we know should be approximately 5.42. So we'll go back to the home screen, and we have common log of 1/2 or 0.5 divided by common log of 0.88, or 0.88 if we want. Enter, and notice how we do get the same value for t, approximately 5.42. Again, we weren't told where to round, so I'm just rounding to 2 decimal places. But this tells us the car is going to be worth half of its original value, approximately 5.42 years after the purchase. And let's write this as a sentence. The car will be worth half of the new purchase price after approximately 5.42 years. I hope you found this lesson helpful.